Today we're going to take notes on section 11.8. This is the last section in chapter 11. After this, we have a review day and then followed by the quiz that will cover sections 11.1 through 11.6 and then 11.8. We're going to learn about Hero's formula and Brahmagupta's formula. So for Hero's formula, that's the first one. It allows you to get the area of a triangle. And yes, you already know that the area of a triangle is equal to 1/2 base times height. And the base and the height have to form a right angle. Well, what if you don't have a base and a height, but you have all three sides, none of which form a right angle with each other? Then you would use this formula. Hero's formula would be the square root, and it's a long one, of s times s minus a times s minus b times s minus c. And you're like, what do the s, the a, b, and c stand for? Well, a, b, and c would be the lengths of all three sides of the triangle, and s is the semi-perimeter. The semi-perimeter would be a plus b plus c, which are all three sides. So that's your actual perimeter divided by 2. All right, next we have Brahmagupta's formula. Brahmagupta. This formula is used when you have a quadrilateral inscribed inside of a circle. So a cyclic quadrilateral. The formula would be the following. Again, we have a long square root, and it's just going to be s minus each side. So s minus a times s minus b times s minus c times s minus d, where a, b, c, and d are the sides of the quadrilateral, and s, again, is the semi-perimeter. So we have the 4 sides, a, b, and c, and d, added together, divided by 2. Let's use these formulas in examples. So the first example we're going to have, it's going to tell us that the sides of the triangle are 3, 6, and 7. Let's figure out what our semi-perimeter is first. So that would be 3 plus 6 plus 7, which is the perimeter, divided by 2 will give you the semi-perimeter. So we have 16 divided by 2, which gives us a semi-perimeter of 8. The triangle's formula would be the square root of s, which is 8, times 8 minus one of the sides, 8 minus another different side, and 8 minus the other side. And then let's simplify this. So we have 8 times 5 times 2 times 1. So 8 times 5 is 40, 40 times 2 is 80, times 1 is 80 again. So we have the square root of 80. Then, in order to simplify this, 16 goes into 80 5 times. So this would be simplified as 4 root 5. And since we're finding the area, we'll have squared units. And that's it. That's how you use Hero's formula. Now, let's go on to the next example. The next example has find the area of an inscribed quadrilateral with sides 2, 7, 6, and 9. Okay, so first let's find the semi-perimeter. We have 2 plus 7 plus 6 plus 9 all divided by 2. So on top, 2 plus 7 is 9, plus 6 is 15, plus 9 is 24. Divide that by 2 and you have a semi-perimeter of 12. All right, the area formula for a cyclic quadrilateral, we have semi-perimeter minus the first side times the semi-perimeter minus the next side times the semi-perimeter minus the third side times the semi-perimeter minus the fourth side. Okay, let's simplify this. We have 10 times 5 times 6 times 3. All right, so you end up getting, when you do 10 times 5, we have 50 here, and then here we have 18. 50 times 18 ends up giving you 900. So when you take the square root of 900, you get 30, and we'll have units squared for the area. So that is very quick notes on how to use both of these formulas. Obviously, your homework questions will challenge you a little bit more. I will have the video answer key uploaded to Google Classroom as well, so you can refer to that. It is possible with either of these formulas, Heroes or Brahmaguptas, that if you get a negative number as your radicand, so a negative number underneath the radical sign, that it's just not possible. It wouldn't either form a triangle or it wouldn't form a quadrilateral inscribed inside of a circle. So that is, if that comes up, that would be your answer is impossible or not applicable, not possible, something like that. This will conclude your notes for section 11.8.